Hello everyone, this is Ujjwala working as Assistant Professor in St. Martin's Engineering College in the EC in Electronics Communication Engineering Department. Welcome to today's video session. So, this is the session which I am dealing with electrostatics. Okay, coming to this electrostatics, it is in the subject of electromagnetic field and transmission lines. So, you can see the electrostatics. What is meant by electrostatics? Electrostatics, it is a physics which is a branch of science and it implies the study of stationary charges. What are the stationary charges? Whether it should be a rest position. With the rest position, we can vary different types of charge particles. The different types of charge particles are nothing but everyone knows either it may be positive charge or else negative charge. Coming to the positive charge to negative charge, how the electric fields, the lines which it can be transmitted from one point to other point, everything we will learn in the electrostatics. In this electrostatics, it is a branch of physics and it is a branch of science also, which it deals with both electrostatic as well as magnetostatics. Now, in this section, we will purely learn about the only electrostatics. What are the electrostatics? How the force can be occurred or force can be attracted or the repulsion can be done between the 2 points. So, you can observe here it is a positive charge and here it is a negative charge. Coming to these 2 point charges are nothing but either positive or negative. So, according to the charge particles, the force of attraction between of 2 point charges can be occurred. So, in the electrostatics, we have two different types of applications. One is Coulomb's law and second one is Gauss law. So, in this session, we will learn about purely about only Coulomb's law. Okay, coming to the Coulomb's law. Coulomb's law, here you can see whatever the Coulomb's law, it's a 2 point charges. 2 point charges, the force attraction between directly proportional to the product of charge and inversely proportional to the square of distance between them. You can observe whatever the electrostatic attraction or repulsion can be done with either negative energy to positive as well as negative to negative as well as positive to positive. Whether whatever done with negative to negative energy, it can be repulsion. Whatever it can be positive to positive, you can see positive to positive is also repulsion. These negative to positive and positive to positive, these are the attraction of force between each other. You can see the point of force in between the positive to negative. We have to find the distance in between the charge particles. When we have to find out the distance between the charge particles, it comes with d. It comes with d, the force of attraction between two charge particles. The force of attraction between two charge particles. For example, we are giving q1 and q2. We are giving q1 and q2. Those 2 point charges can be repulsion or those 2 point charges can be repulsion. You can observe here the Coulomb's law, the statements of the Coulomb's law, whatever the statement, the 2 point charges, that is q1 and q2, whatever the charge which acts in between, the force of attraction between or repulsion between can be occurred, either it may be positive or negative. Whatever the positive or negative, the force is acting either as a k equal to q1 by q2 by 4 pi epsilon naught r square. This is the Coulomb's law formula. The statement between 2 point charges, whether it may be repulsion, whether it may be attraction. This process can be occurred either it may be positive to positive or negative to negative or negative to positive. Whatever the attraction between positive to positive, it can be occurred in different types of charge particles. So these different types of charge particles can be generated according to the Coulomb's law of the force. These Coulomb's law can be occurred in between charge particles. So you can observe whatever the charge which it is moving with the different particles, with different particles can be done according to the repulsion of a force or attraction of a force. These forces are due to negative to positive and negative to negative as well as positive to positive. Whatever the force which acts with negative to negative and positive to positive, there can be attraction or there can be repulsion. And next we can we can observe the next charge particle. Thus, what is the electrostatic of force can be generated according to Q1 to Q2. This Q1, whatever in the earlier slide, which I have shown, negative to negative, positive to positive, positive to negative, you can clearly observe whether it is in the same charge, it can be repulsion. Whether in the different charges, it can be attracted. The force can be attracted to each other. The force which it acts as F is force, Q1 and Q2 are nothing but charges, and D is nothing but distance, where Coulomb's law of the K is nothing but the constants of a force. So this is the, you can observe clearly in this diagram, in this pictorial representation, how charges can be attracted, how the charges can be repelled to each other. When the charges can be attracted or repelled to, repulsion can be each other, depends upon the Q1 and Q2. So the this you can see, it is a scientist who experimentally formulated the Coulomb's law. He is a Charles Armstrong. He is invented in 1785. And you have whatever we have discussed in the whatever we have discussed in Coulomb's law, 2 point charges. 2 point charges, the force of attraction between either negative to negative or positive to negative charge, which can attract each other, or repulsion can be done with each other. So charges can be measured with Coulomb's law. The Coulomb's law can be discovered with 1.6. The charge can be 6 into 10 to the power of 8 electrons. Each electron can be converted into 1.68 into 10 power 19 coulombs. So the force of attraction between 2 point charges. The 2 point charges are nothing but Q1 and Q2. Whatever the point charges which we can take to repulsion, F equal to K1, K equal to Q1 Q2 by R square. So where F equal to K Q1 Q2 by R square. Whatever K is nothing but is a constant of force which it can be done, where K is a proportionality constant, where K is nothing but we can observe K equal to 1 by 4 pi epsilon naught. Here epsilon naught is nothing but your probability of free space. We can, if we are finding with a different dielectric material, here we can easily get epsilon equal to epsilon naught epsilon r. Here epsilon naught epsilon r is nothing but your permeability of relative permeability. Here epsilon naught is the value which we can find out the measure. So epsilon is the permeability of free space. We can see 8 into 8.54 into 10 to the power of minus 12. The formula which it can be, K is a constant, K is equal to 1.45. So whatever the 2 point charges which it can be done according to the force which acts between 2 point charges. This is a line charge, this is the line charge, this line charge which the Q1 and this is the Q2. Whatever the force which it can be generated according to the force between the reflection can be done according to the Q1 and Q2. Whatever the force which we are occurring depending upon the different types of charge particles, that is which we have to find out here the vector notation. That vector notation can be represented as R12 vector. The force which acts as Q1 to Q2, that can be notation can be denoted as R1 and R2. The vector notation can be denoted as F12 to F1. So substitute this equation in the Coulomb's law. The equation of the Coulomb's law, what we have to substitute, that is nothing but F equal to K Q1 Q2 by 4 pi epsilon naught r square. This formula we have to substitute. There K is nothing but constant, so directly we can written as Q1 Q2 by 4 pi epsilon naught r square. Next, by substituting the vector notation, that R1 to R2 minus R1, that is nothing but vector which we can find out the unit vector, that is A bar. A bar equal to A by mod A bar. It is the notation which we can easily identify the vector notation. So the A12 is nothing but R12 by R. Substitute the equation in the Coulomb's law. The Coulomb's law, which it can be stated that the force of two charges, that is F1 and F2. So it is whatever directly proportional, that is can be generated with F21, and whatever it is inversely proportional, it is nothing but minus F12. So the force of attraction between the two charge particles can be occurred like this. Okay, and next we have to see the, up to now we have observed only 2 point charges. If we can observe with different n number of charges, means we have to give, if the charge of the, it is a point, the point can be occurred with different charge particles, that is q1, q2 and so on, like this, q1, q2 and so on up to qn. Whatever the n charges, when we are giving n charges, the in between the charge is nothing but q. The charge q is moving with q1, the charge q is moving with q2, so on up to qn. So directly we can write the formula with q qn by 4 pi epsilon naught r square. This directly we can see, take the common of q by 4 pi epsilon naught k to 1 and q r by r minus r k by mod r minus rk whole cube. This is the formula which you can see Coulomb's law due to n charge distribution. For single charge distribution, we will give only q1 and q2. For n charge distribution, we will see only q2 q1, q2 q1 to q2 q3 and so on to q2 qn. These are the n charge distribution, and this is the, in the earlier slide we can see up to here it is Coulomb's law. Okay, in the electrostatic of a force, which it can be attracted or repulsion can be done with the 2 point charges. Now we have to observe the electric field. Whatever the point charges which it are moving from one point to other point, the electric field can be generated depending upon the E, the force F, electric field, whatever the force which it is moving from one point to other point, some electric can be generated, some force can be occurred. This it can be considered as E bar equal to F bar by Q. So you can see E equal to F by Q. F is nothing but what are the force which it can be occurred in 2 point. Whatever Q is nothing but charge, and E is nothing but your electric field intensity. So electric field intensity can be observed E equal to F by Q. Whatever the more number of charges can be occurred due to the particular location, we can identify E equal to F by Q. So E equal to F by Q means already everyone knows the equation of a Q. Q is nothing but a constant charge, whatever the charge which it can be generated. So Q by 4 pi epsilon into A r bar. When we are finding with some vector notation A r minus r1 bar, it can be written as A 4 pi epsilon r minus r1 whole cube. When it is due to n charge distribution, directly we can observe 1 by 4 pi epsilon qk by r minus rk by whole bar whole cube. When we are taking the difference between the Coulomb's law and electric field intensity, where the Coulomb's law, when we are giving with 2 point charges, the 2 point charges are nothing but q and q1, but electric field intensity directly we are giving only charge, that is nothing but q. So directly the charge which it can be generated, it can be q. You can easily observe the Coulomb's law, which F equal to q1 q2 by 4 pi epsilon naught r square. This is Coulomb's law. Coming to electric field intensity. This electric field intensity, the equation is 1 by 4 pi epsilon naught q by r square. So directly we can written as only q by 4 pi epsilon naught r square. This is the equation which is the commonly difference between the electric charge as well as magnetic charge. Now we can observe the next in the electric field due to n charge distribution, we have to identify with the different repulsion, different attraction can be occurred. These different attraction or repulsion can be occurred depending upon the force of due to n charges. When force on due to n charges can be generated depending upon the Coulomb's law and as well as electric field intensity. When this electric field intensity can be generated depending upon the number of charge particles. This number of charged particles can be done according to the electric field intensity. Okay, this electric field intensity with q charges as well as n charge distribution. So n charge distribution directly 1 by 4 pi epsilon naught qk r minus rk by mod rk bar. When we are giving mod rk bar, and these are the different charge distributions we can see. You can observe these are the four different types of charge distribution. One is point charge and line charge, surface charge and volume charge. Point charge. Point charge means where we can keep anywhere in a different particles, either it may be positive or negative charge particles can be occurred. The point has a node, it is a dimensional less, so the charge can be occurred at anywhere. Coming to the line charge, the line charge you can take any points of 2 points from one point to other point. That line we can take a one line and we can give a some charge distribution. So simply we can call it as a line charge between the 2 point charges. This is also called as Coulomb's law also. Coming to surface charge, surface charge is nothing but take one plain sheet. In the plain sheet we can easily we can easily generate positive as well as negative charge particles. Whether the positive or negative charge particles, depending upon these surface charge, is nothing but in a thin sheet wire. Coming to volume charge, what are the spherical devices which in cylindrical purpose, there we can easily observe the volume charge. So these are the different types of four charge distribution. So these are the four different charge distributions. These different charge distributions are point charge, line charge, surface charge and volume charge. So the point charge is nothing but it is a dimensionless charge, whatever we have discussed. And line charge, the line charge can be denoted as integral L rho L dl. So the formula which we can depends upon by depending upon the line charge. Whereas similarly we can take as the surface charge integral S rho S ds. We're coming to volume charge integral V rho V dV. So these are the three different types of charge particles which we can observe depending upon the various charge distribution. It can be indicated as rho L, rho S and rho V, whether it is a line charge, surface charge as well as volume charge. So whatever the charge which you are moving, it can be depending upon this integration of rho L, rho S and rho V. So these are the three different charge distributions which we can observe. Okay, next we can, whatever we are observed, we have to mode. So already I have said the charge, the charge q is nothing but your rho L dl, the integral L rho L dl. This integral L rho L dl is nothing but this rho L is nothing but your charge of location of q. This charge of location q is nothing but which we can identify with q equal to 1 by 4 pi epsilon naught r square. This one is nothing but the charge which it can be. The q is nothing but here rho L dl by 4 pi epsilon naught r square. So this is the formula which we can identify is the E equal to integral rho L dl by 4 pi epsilon naught ar in the line charge, whereas the surface charge with the rho S ds, whereas the volume charge rho V dV. So these are the three different types of charge distributions can be occurred with the three different ways. Now you can see the purely about the line charge distribution. The line charge, whatever, so you can easily identify this diagram which it is identify the 2 point distributions. These 2 point distributions can be identified with a line charge with a coordinate system 0 0 h. Here coming to why we are discussing about the coordinate systems, in there are the three different types of coordinate systems as everyone knows. In the Cartesian coordinate system, Cartesian or coordinate system, in the Cartesian system we can easily can be called it as the xyz, where cylindrical coordinate system can be called it as a r theta pi, and coming to spherical coordinate system can be called it as a rho pi z. So for cylindrical rho pi z phi you can see. So different Cartesian, for generally we are taking one line charge. So generally we are taking means we can directly you can use as a Cartesian system. The Cartesian system is xy Z. Z is the point, whatever the axis which the evolution of field can be moving at a particular point. These point can be generated depending upon different line distribution. These different line distributions can be generated according to the force of attraction between the 2 point charges. Whether, and next you can see, and next, by using this formula dq, total charge which is rho L dl, so nothing but rho L dz. So the charge q is nothing but 2 point charges. The 2 point charges is nothing but a to b. So whatever you are taking the point charge, the point charge, so for example, we are taking 2 points. These 2 points are moving and attracting with each other, that is a B. This point can be generated depending upon with rho L. The rho L of the total charge which the attraction of the force can be done according to the repulsion of the work can be done is integral of A to B, and total charge which it can be denoted as rho L dl. This rho L dl can be indicated depending upon the 2 points or the 3 points, whatever the force which it can be occurred. These forces of the electric field intensity due to line charge means E equal to rho L by 2 pi epsilon naught by rho by a rho. And next, this is the line charge. Next, we can move to the surface charge. You can already have the surface charge, whether it is a sheet material. You can easily observe the sheet, whatever the sheet, which it can vary. Here, when we are varying, we are taking some point of force, which it can be repulsion can be generated. So these points, the point, this is point 1 and this is point 2. Whatever the point, that is 1 and that is 2, the force of attraction between the angle which we have to find out the in between the 2 points. When we are finding in between the 2 points is uniformly charged distribution and surface charge distribution which we can vary. So rho s ds. In the evaluation of electric field or different infinite line or sheet charge can be generated depending upon the three different types of charge distribution. When we are defining with the second charge distribution with a sheet charge, the sheet can vary according to rho L as rho S. The rho S and rho L, the indicator, whatever the angle which you are moving with a H azimuthal angle of the phi is moving to point to point, point to point. And next we can see this formula can be denoted as same earlier how we have done at line charge, q equal to integral rho L dl. So similarly q equal to integral rho S ds. Whatever the charge which you are moving with a electric field, dq by 4 pi epsilon naught ar. Here dq is nothing but your rho S. What are the surface charge which it is moving, rho S by 2 epsilon naught q n bar. It is a different position at surface charge. Coming to the volume charge distribution with a uniform charge density is rho v. Volume, it is a spherical structure. In the spherical structure, we can easily identify with 2 point charge distribution. When we are identifying with the 2 point distribution, here we have to find out one node. This node can be either it may be 0 comma 0 comma z, either it may be r comma theta comma phi, whether it is in a Cartesian system or whether it is in a spherical system. These two systems can be involved depending upon the rho charge of a both fields of a magnet. When it depends upon the both field charges, it can be generated with this pair of radius, that is integral rho v by dv. When it can be integral rho v by dv, it depends upon rho v q, the q of the charge which it can be 4 pi epsilon naught by 4 pi epsilon naught r square by ar bar. And this, the symmetry axis can be generated in depending upon the electric field intensity. When it can be depending upon the electric field intensity, the charge distribution can be occurred depending upon the more number of charge particles. So these are the different types of charge distributions, whether it may be line charge, surface charge, as well as volume charge. When the different types of charge distribution can be occurred, either it may be positive to positive, either negative to negative. Whatever we have observed till now the section, just briefly completing about negative to negative, positive to positive, positive to negative. The electrostatics, which it deals with branch of physics and all the science which it can be mathematically generated, and whether it can be electrically forced of the attraction or repulsion can be done between two point charges or two any charge particles can be occurred. So whether the charge particles can be either, it may be different charge distributions can be generated. These charge distributions can be generated depending upon the mm, field materials, the materials which we can see, the point charge as well as volume charge as well as surface charge. Again, briefly, we can see the note of the Coulomb's law, and we can observe the electric field intensity, and briefly we can observe the charge distributions. You can see the first we have observed the electrostatics of the force. The electrostatics of a force which it can be generated, either it may be positive or negative charge particle, whatever it may be charged to, whatever it may be positive or negative charge, it can be generated depending upon the two laws. The two laws are nothing but Coulomb's law as well as Gauss law. So the major which we have to observe here, only Coulomb's law. The Coulomb's law of the force, which it can be attraction between two point charge particles as well as inversely proportional to the square of distance between them. That is nothing but F equal to K equal to Q1 by Q2 by 4 pi epsilon naught R square. Whether these charge particles can be depending. So coming to your Gauss law, the Gauss law can be generated, the Gauss law can be generated of F equal to K equal to Q1 Q2 by 4 pi epsilon naught R bar cube. So electric field equal to E bar equal to F bar by Q. Coming to different point charge distributions which we can vary with with a with a vector, it means E bar equal to F bar by Q. When we are finding with a force due to the n charge particles, E bar equal to Q. These are the different charge particles we can observe. Coming to the charge distributions, the charge distributions which we can see here in Coulomb's law or the electric field intensity are, the first one is point charge. The point charge can be either, it may be dimensionless charge. Coming to your line charge, line charge can be any point axis, the point which it can be denoted, so it is rho l. And coming to the surface charge, it can be denoted with a some sheet material surface, so I am consider this is a surface, this is rho s. Coming to fourth one, that is volume charge. The volume charge which it can be generated some any material or any structure. In this structure we have to identify the volume, that is rho v. So these are the four different types of charge distribution which we have seen. These four different types of charge distributions can be easily generated, and those easily can be occurred depending upon the process of the Coulomb's law as well as the electric field intensity. These different charge particles can be done depending upon the repulsion or attraction between the two point charges as well as the force of attraction between the infinite of the line sheet or the volume or the any other material of the phase. When we are giving some dielectric material, the dielectric material can be observed is depending upon the charge distribution or depending upon the attraction of the force which it can be generated, of the material. So when we are giving here different materials of the different force or different charge particles can be either maybe attractor or repulsion can be generated. Whatever the field of force of the lines which it can be generated is depending upon the compulsions or mutual coupling can be occurred in between the two point charges. So here we have learned about different types of charge distributions, and we have learned about the electric field intensity, and Here we have learned about the Coulomb's law also, how the force can be occurred, how the force can be generated due to the electric field intensity, how the force can be mutually over coupled with different charge distributions are seen in this session. In the next session, we can see the next topic of the application, that is a Gauss law. Yeah, thank you everyone for watching this video.